Hi, today we're going to talk about sample space and simple probability. This is the start of our probability chapter. So I have highlighted in blue terms and definitions that you need to know in this section. And then in green will be our examples. So first of all, probability experiment. It's just a chance process that leads to well-defined outcome results called outcomes. So when we do a probability, toss a coin, roll a die, we call that an outcome. An outcome is just a result of a single trial of some experiment that we do. Sample space is all the possible things that can come out of a probability experiment. So all your possible results. So example one is saying list the sample space. So it says list the sample space for rolling a single die. So we just list what we see on a single die. So we can get a 1, a 2, a 3, a 4, a 5, or a 6. We put them usually in little brackets. That is the sample space. Pretty easy. Okay, it said looking at the spinner and tossing a coin. What are all of the possible things? So I'm going to toss the coin first just because it's kind of easier for me. So if I toss a coin, I can get heads or tails, and then I'm going to spin the spinner. Well, on the spinner, I can get 4 different colors here. So I can get heads red, heads and then green, heads and then blue, heads and then I guess that's orange. Or I could get a tails on the coin and get red, tails on a coin and get blue, tails and get green, or tails and get orange. So those, for that one, there's 8 different outcomes in that sample space because I did 2 different things. Where the 8 comes from, and we never talked about counting techniques, but where the 8 comes from is there's 2 things that can happen when I flip a coin and 4 different colors on the spinner. So 2 times 4 is 8. That's where you get all of your sample space. Okay, so a tree diagram sometimes is good for this when you're doing multiple things one after another to make a chart called a tree diagram. And that sometimes helps you come up with all of the different types of outcomes. For example, for this one above here, here's a tree diagram. So you have heads and tails on the coin, and then you get red, blue, green, or orange on the spinner. You could get tails on the coin and then get red, blue, green, or orange. So here's your 8 outcomes: heads and red, heads and blue, and so on. Same thing, but the tree diagram helps you when you have a whole bunch of different outcomes. All right, so we're going to toss 3 coins. So we're going to toss one, then the other, then another. Or you can toss all 3 at the same time. It's really the same thing. So if somebody says you're going to toss 3 coins, you can toss them all at the same time, or you can toss one and then another and then another. The number of outcomes are the same. So on the first coin, we have heads and tails. I'm going to kind of write them out far apart so I have enough room. Second coin, heads, tails, heads, tails. And then I'm going to toss another coin, and I can get heads, tails, heads, tails, heads, tails, heads, tails. So if you look at this, there are actually 8 outcomes: 1, 2, 3, 4, and so on. We're going to go through and we're going to write them. So the first thing that could happen would be heads, 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 heads. Or you could get heads, heads, tails. I'm just going through the branches. I call them branches through the tree diagram. Heads, heads, tails. Next one, I can get heads, tails, heads. Or heads, tails, tails. Okay, next we'll set down here. I could get tails, heads, heads. Tails, heads, tails. tails, tails, heads. Tails, tails, tails. Okay, so this is your outcome for tossing 3 coins. If you can see this, there's 8 outcomes because you toss 3 coins. There's 2 on the first one, 2 on the second, 2 on the third. 2 times 2 times 2 is 8 different things that can come out of it. You could also use this if you're talking about 3 kids in a family instead of 3 coins. So I could change this to 3 kids and maybe make the H's boys and the tails girls. And that will give you all of the combinations. For example, if you're having a probability question in your homework that says, what's the probability of having 3 kids? I can change that to kids. And what's the probability of having 2 boys and a girl? Well, I could have 2 boys and a girl here, 2 boys and a girl here, 2 H's and a T, or 2 boys and a girl here. So there's 1, 2, 3 outcomes out of 8. So my probability would be 3 out of 8 of having 2 boys and a girl. It's taken a long time to change, isn't it? Okay, the next one. An event consists of a set of outcomes. So that means just you're going to be doing maybe 1 or more things. All right, so we're going to talk about 3 types of probability, and they're going to be highlighted in yellow. The first type of probability is called classic probability. It uses just looking at the sample space to determine the probability. You haven't done anything. So it's kind of what we call sometimes theoretical probability. Okay, you haven't done an experiment. So no experiment has been done. You haven't actually picked up a die. You haven't actually flipped a coin. You haven't done anything. You're just looking at the sample space to calculate the probabilities, and that's what classical is. This is a standard deck of cards. For those of you that do not know what a standard deck of cards looks like, there's 52 cards. These are clubs, spades, hearts, and diamonds. I strongly suggest you going to YouTube or Wikipedia and learning a basic deck of cards. You're going to have that throughout the chapter. You're going to need to know what a basic deck of cards is and what numbers are there. Okay, so example 3, it says, a card is drawn from an ordinary deck of cards. Find the probabilities. Okay, so this is going to be out of 52 because there's 52 cards in the deck. And we want a jack. Here are your jacks. Right here. So we have 4 out of 52 jacks, which simplifies to 1 out of 13. If you're having problems with simplifying fractions on your graphing calculator, you will type in 4 divided by 52, hit the math button, and then the frac button, and enter, and it will simplify fractions for you. All right, next. A 6 of clubs, 52 cards in the deck. You want a 6 of clubs. There is only 1. Here's your 6 of clubs right there. So 1 out of 52. So this is classical probability because I'm not actually picking up a deck of cards and doing anything. That's why it's called classical. Okay, a 3 or a diamond. Okay, so there are 4 3s. I'll show you up here. Okay, plus, could be either or means add. We'll talk about that in another video, or a diamond. So it could be any of those cards. So here are your diamonds, 13 out of 52, but I counted 1 twice. This one right here. So I have to subtract that out because I counted that twice, and we'll talk more about that in the next video. But you have 16 out of 52 cards that are either 3s or they're diamonds. That simplifies to 4/13. and I'll show you up here. Let me go back up to the deck of cards. So if I look at it, let me highlight. I want a 3. Okay, so here are my 3s. So there's 4, and then here are my diamonds. If I counted all those up, there's 4, and then there's 13 here, but I already counted this one. So I kind of counted it twice. That's why I subtracted it out. For now, you can just count them up. So that's 4 and then plus 12 more. You can just do it that kind of that way for right now. Right? So my next one. 3 or 6. So there are 4 3s and there are 4 6s. So I just add those up. And we get 8 out of 52, which simplifies to 4 goes into both, 2 out of 13. Okay, next one, 8 or hearts. Okay, out of 52, once again, 8, there are 4 8s, plus there are 13 hearts, but I counted one twice, so I have to subtract that out. So 16 out of 52, and I'll show you again how I got that, equals 4 out of 13. So if we go up here, again, and I'll do a highlight for you. Okay, and we'll highlight in green this time. Okay, my 8s are here, 4, and then my hearts are here. 13, but I counted one twice. So for now, you can just do 1, 2, 3, 4, and then count the rest was 12, which is 16. You can just do it that way for right now. And then my last one is 4 and a spade. Okay, so there are 4 4s. So again, there are 13 spades minus, if you count them again, you counted that 4 of spades. Oh, no, I did that wrong. Oops, sorry. I did that problem wrong. It's an and. Oops. Ignore what I just said. I thought it said or. It's 4 and a spade. Let me go over that again. Sorry. 4 and a spade. So let's go up to the top here. And let me clear some of this out. Okay, so we want a card. If you're looking through that, it has to be a 4 and a spade. I read the problem wrong. So a 4 and a spade. So here are my 4s, and it also has to be a spade because it's the word and. And means you have to have both things, right? So it's basically the 4 of spades. So you can kind of read the problem like that. So it's really just the 4 of spades. There's only one of them, 1 out of 52. Okay, next page. Okay, your basic rules of probability. Basic rules of probability. Put this in a little text box for you. Okay, basic rules of probability. First one, the probability of an event. Your probability event has to go from either 0 to 1. Okay, it has to be either a 0% chance or a 100% chance of happening. Okay, next one. A probability of an event that cannot occur is 0. Can't happen, it's 0. Okay, a probability of event that's certain to happen. 1. Okay, and then your sum of your sample space, the sum of all the probabilities, have to add up 100%. Can't be less, can't be more. So the sum of the sample space, which is all the probabilities, okay, is 1. All right, those are your 4 rules of probability. Putting that up there a little bit. All right, complementary events. Complementary events is just kind of the opposite of what you want. So it's the set of outcomes that are not the things that you want. So you do whatever you want, and then you do the opposite of it. For example, the complement of getting a 5. In this book, different books write it differently. In this book, we write it the probability of 5 with a bar over top. So if you see a bar over top, that means that's the probability of it not happening, the opposite of what you want. Okay, so if you roll a single die, this is talking about a single die. There are 6 outcomes in a single die, and the probability of getting a 5 is 1. So that means the complement of it is 5 out of 6. Okay, so complement is basically 1 minus what you want the complement of. Right? That's a complement. It's just the opposite of what you want. So when you see that bar over it, that's what that means. All right, empirical probability. That's our second type of probability. We had classic, where you just look at the sample space. And now we're going to do empirical probability, where you actually gather actual data. You actually roll dice. You actually pull cards out of a deck. You actually play a game. This one deals with blood types. So they actually gathered a sample of people and their blood types. And I believe when you add this up, it adds up to 50. So the total is 50 people. So that's going to be our denominator. So this is called empirical probability because we're not looking at theoretics. We actually gathered 50 people and looked at their blood types. So the probability of getting blood type B is 5 out of 50. And then you simplify it to 1 out of 10. Probability of A or O, so you could have either. So you just add the two together, A, O. Just add them together, you get 43 out of 50. That we cannot simplify. Okay, this is not B. So remember, that would be the same thing. If not B is the same thing as probability of complement of B. So we look at B. B has 5. We want not B. That means all the other 3. So that would be 45 out of 50. There's a little complement symbol, which simplifies to 5 goes into that, 9/10. And then the other one is neither A, B, or O. So I was reading that is neither A, B, or O. So I thought that meant neither the both of them. Should say neither both A, B, or O. We should put that words in. Okay, so here's A, B, and O. That's 23, so that would be the complement of it. So A, B, or O is 23, so we want these two. So it would just be 27 out of 50. Okay, so remember, empirical, you're actually using actual data to do it. Okay. You're actually doing, think of empirical, you're actually doing some kind of experiment, like rolling die, actually doing things. All right, and then the last thing in this section is our third type of probability, which is called subjective probability. And subjective probability isn't really like real like probability that we think of. People say that it's probability, but it's really not. It's an educated guess. It's an opinion that you may have. It doesn't mean you're just guessing out of thin air. It may take some kind of education or some thought or some knowledge or skill, but it still is kind of an opinion, like weather forecasting. Okay, weather forecasting is subjective. You look at your data and your charts and you're saying, oh, I think there's a 40% chance of rain. It's still a percent chance, but it's not our rules of probability. Another thing is the probability you think of your team winning. So you may look at where you're playing, where you're playing, whatever you're doing, and you say, oh, there's an 80% chance of that team winning or something like that. That's still subjective probability. It's not using the laws that were a probability to calculate it. So any kind of opinion or educated guess is subjective probability. So in yellow through these notes were our three types: classical, that's just looking at the sample space; empirical, which is actually doing an experiment based off of data that you did; and then this subjective, which is just not really our probability laws, but people use it as a probability and say, oh, there's this percent chance, or there's a 3 out of 5 probability that you're going to win the game. That's subjective probability. And that is it for this section.